which are deteriorating. It's quite known fact that use of fertilizers is increasing and production kind of balancing. So fertility of soil is a temporary dynamical variable. Is it possible to take it into account? What is the long-term prospects for soil health and fertility?
Gosh, thank you. I think there are probably better people to answer some of that question than me, but I would certainly strongly concur with you that soils are four-dimensional, in that the time dimension is very important. And in a lot of the models that we've been hearing about, the time element of soils is only represented in terms of soil water content. It's not represented in terms of the varying physical properties of soils associated with compaction, with erosion, with loss of soil organic carbon. And I think most of those things can be or are represented in some models, but they're not necessarily integrated into the systems perspective, particularly with sort of land use management decisions. I think there's definite scope for that, but it's not happening yet. And I don't know whether you want to say anything more about soil?
That's all yours.
Yeah. Right, all right, we have plenty more. So I've got Marcel at the back, and then I can see another couple more.
Okay, thank you for interesting talks. One thing when you couple existing models is, of course, that via the whole network of coupled models, the output from an individual model can ultimately be linked to its own input with feedbacks as a result. If these are positive feedbacks, you can get runaway behavior of the whole system. So I have a concrete question to Ian, actually. You have these examples of the behavior of models stand alone and as part of the network. Did you come across examples of submodels, sectoral models whose behavior deteriorated from incorporating in the network?
When you mean deteriorated, do you mean the performance of the model or the sort of the state?
No, really becoming unrealistic, things dying that should not die, things like that.
No, but we did manage a scenario, an environmentally friendly scenario where we chopped down all of the trees in Europe. And that was this this challenge of a scenario with a de-intensification, agricultural de-intensification, combined with reduced imports and increasing food demand. And the only way that the model managed to achieve that was by converting all the forestry to agriculture.
So in general, you see the coupling as a fairly safe and positive thing to do, except in extreme combinations of scenarios.
I think the advantage, well, isn't it advantage or is it a disadvantage? Within our platform, the model just runs down. There is no feedback then back to the beginning. And we actually, because it's an interactive platform designed for users to interact with, it has a runtime for Europe of about 2 minutes. The idea is the user is then the feedback mechanism through changing the inputs, rather than the model continually looping and going down into those sort of endpoints that you were describing.
Yeah, just I was all a bit incestuous, really, isn't it? But I was involved in that study as well, and it was led by Callum. But when we set off doing the study, looking at the uncertainty, the idea was to try and explore whether you'd get convergent or divergent behaviour, which is a little bit what you're referring to. And we had no preconception of what that would look like. The outcome, as Ian showed, was convergence. And I was having a conversation with Peter, actually. I don't know if you want to mention anything about this, Peter, but it does seem to be that there's some sort of theoretical underpinning that where you start introducing more feedbacks into your model systems, that often seems to be leading to more convergent behaviour rather than divergent behaviour. I don't suppose we necessarily know why that is, but it does seem to be a case that often comes up in a lot of these model systems.
Okay, we have lots and lots of questions here, right? Fine, move on.
Yeah.
Okay, so it's Nick, I think, is it? Nick?
So there's clearly a huge amount of work that's gone in from all of you in trying to couple these very disparate models together. And that looks to me as an outsider an extremely complicated and involved business. Do we need to have a conversation about standards and buy-in from the modelling community so that when people make models, they conform to some standards, and that facilitates them being clicked into your nice little frameworks for joining models together in a more simple way? I'm struck by an XKCD cartoon that as soon as someone mentions standards, you end up with N+1 standards. So is there efforts in the community to generate standardization of input and output from classes of models that can then be used centrally?
Yeah, I totally agree with you, and I would like to suggest that Gordon answers that. Although I would say in the agent-based modelling field there are some standards that have been used in terms of protocols for how you describe models, but that's not so much to do with model coupling. Anyone want to say something?
No, I'll pass that over.
Oh, I get the hot potato, thank you. Yeah, I mean, as a computer scientist, I've got a love-hate relationship with standards. They are fantastic, but the problem is we've really screwed it up. As you rightly alluded to, whenever you look for standards, there's so many of them to pick from. There's too many standards, there's too many competing interests. The last time I was involved in building a modelling framework, what we elected to do, if you excuse me getting a little bit technical, is rather than coming up with an all singing, all dancing standard that would represent any model, is that we opted for a very simple solution, and I think that was the right one at the time, and maybe the right one now. It was RESTful APIs. Now, if you don't know what that means, buy me a beer later and I shall explain it all beautifully. Very simple standards, because standards get too complicated too soon and just don't work. So my preferred strategy is keep the standards simple, adopt RESTful, and then maybe use ontologies or metadata to decorate what's behind the scenes so you know more about what it is. I think that could work beautifully in this integrated modelling community, but yet to be tested.
Just building from that, yeah, we decided in our projects not to adopt any of the standards, but but the data dictionaries were the way of providing the clarity that in principle, any model that adhered to the data dictionaries that we specified for those data transfers could be integrated into the platform. We never actually did it, but in theory, it was the sort of practical, low-effort cost of ensuring some degree of standardization that was transferable.
Yes.
So I've had it's nice to hear about model coupling. I've had some painful experiences with model coupling. And even coupling models that seem similar. I'm wondering what's lost in translation, and I like that perhaps Rob's work has tried to look at what's lost in translation when we're coupling, and I'm wondering how, if we were to think about it quantitatively, how important are those uncertainties compared to the overall uncertainty? Do you have any intuition about that? And perhaps is there a solution for it that Gordon can help with?
I think the approach that we took with the emulation, we would probably argue that there was more lost in developing the emulation, but the benefits derived from the coupling and that more systemic approach, the word's gone, was more worthwhile. That was the greatest benefit, but I would agree there's certainly things are lost.
Yeah, I think that the benefits are also, you have to appreciate that it's also like a social process when you're coupling models, and the benefits are also from the learning you get from the shared experience of trying to do a bloody
Painful,
difficult thing.
but also,
Yeah, exactly.
at the end.
Yeah,
Growth. It's a growth opportunity.
it is exactly. Absolutely, yeah. Team building
It
and all that.
certainly was for the wine industry. I think supporting
Wine
it.
is quite critical, yeah. I forgot what I was going to say now. I must have been the wine. Yeah. No, I'll come back to it in a moment.
Yeah. Well, Lost in Translation was one of my favourite movies.
Mine too.
Yeah, but I mean, when I first moved into this world, the first thing I did was spent a sabbatical in CEH, and I studied some integrated modelling projects, and I was horrified. I'm not going to go into too much detail in case you know the science involved, but I studied one Nature paper. That's all the clues you're getting. 2 coupled models. The first one very sophisticated, the second one very sophisticated. The transfer function adopted in the middle, nobody could justify. You know, someone knocked that together in in half an hour, and there was no scientific basis for that particular piece of code or that scientific analysis that took place. And that to me is like buying your great speakers, your great CD player and a rubbish amplifier. It's lost in translation. So that shouldn't happen.
Very quickly, Mark. We have
Yeah,
lots
it's
of
a
other
member.
questions.
Yeah, the other point, I agree entirely with what Gordon was saying earlier. It's actually often the connections which are more interesting, and they should be in a sort of cross-disciplinary perspective. We should be really seriously thinking about the connectivity between elements, components of the system, as much as the individual components. Part of the problem is it does take a lot of effort to do coupling, and that might be just because we do it badly, and hopefully Gordon can tell us at the pub later how to do it better. But the problem is because it's hard, you often end up spending a lot of time just doing it one way. So you never have any alternative or counterfactuals that you could do a comparison with. This is better than this way or that way, etc. We don't do much experimentation on the ways in which we do coupling. We just do it because you have to get on with it.
Okay, we have 2 over there. It's just
I just had a couple of comments that the panel might hopefully reflect on. It's just going back to first principles of keeping the models simple but not simplistic. And in terms of the, to make sure they're not simplistic, we have to challenge them with data. And I think the policy demand for some of these models is so much at the moment that even very simplistic, potentially simplistic models like, benefits transfer type, lookup tables, they're actually looking at those to inform net gain. And so I think from this workshop of experts, an easy win would be actually to look at some of the principles from robust modelling from climate science, let's say, to think about lessons that can be learned for modelling land use decisions. And actually, I wouldn't underestimate that that there's a lot of good knowledge that could just be synthesised that, because it's a bit like the Wild West of ecosystem service modelling out there. There's some very simplistic models that need challenging. But coming to the other side, the simple part, the models you've described, the highly coupled kind of models of models, it's a bit like Lord of the Rings, that kind of one model to rule them all. Of course, modelling the whole global socio-ecological system over the next 50 years may need that kind of complexity. But for the types of policy questions where we're saying, how might a policy about woodland planting over the next 5 to 10 years, affect delivery of flood risk, protection, of recreation, of pollination? And in some cases there, you might want a small coupled model, looking at the flood risk, coupling the climate and the hydrology, as Simon Dudston sort of described yesterday. But in some models, you might just have a sectoral model, as you called it, like a recreation model that just sits alone. And so I'm just wondering if there's some consideration of which aspects you might want to couple and which ones you don't. The sort of middle ground, I guess, in terms of the complexity.
great questions. I'm sure you're desperate to take that one.
I think the only thing I would say to the last bit is I always think the definition of a model that I give to my students is that it's a simplified representation of a real system for a particular purpose. And the purpose being the question, to some extent, determines the level of complexity and the amount of coupling that you require to appropriately simplify the representation of the system that you're interested in. I don't think there's one size, obviously there isn't one size that fits all questions.
Yeah.
Always get something to say.
Yeah.
Yeah, I think you get to a level of complexity with integrated models where perhaps you have to embrace other approaches as well. I mean, I'm not a big fan of AI. I hardly ever use the phrase, but I do think, given the complexity and the amount of data we have about ecosystem services, that we need a lot more experience of the role of machine learning or deep learning or alternative strategies to let the data speak. I would introduce a caveat. That's dangerous because science is all about understanding process. So I think we'll have to find some sort of way of bringing these two worlds together.
Okay, great. So the lady behind.
Yeah, so I have a question that you might not want to answer. It's for Ian and Mark really, because I have big team envy at the moment, and I'm sitting here thinking, you know, you've already done it. You've done what DEFRA appears to want. So and there is lots of other people out there. Some of them are using lookup tables. Some of them are trying to develop their models by themselves because they perceive that there's no way of getting the funding to do the big team stuff. So I wondered how much money and how many person-months did it take to do those projects you were describing? And then if all of us in this room and all our research groups jumped on board and helped you for the next 3 years, how much better would we be at the end?
Go on.
Model is yours.
We're always delighted to have free labour offers. So I'll give you my card later. Oh, we have to pay you. Okay, you didn't say that. It's really difficult to know. I mean, most of these models, like most models, are sort of evolve through time. They have different starting points, and sometimes they have endpoints. And the LPJ guest model I was talking about has been around for 20 or 30 years. That's been massively resourced and tested and developed, and has contributed to. It's effectively a community model by people all over the world. The agent-based modelling is sort of Callum and his dog, you know, over the last 2 or 3 years, I think, isn't it? I mean, it's actually quite a small amount of resources that go into that. So, and I think there still is, and I don't want to get on my hobby horse here, you know, if you've got big team envy, you know, I'd like to see the Hadley Centre for Land System Prediction, but I've got big team envy about what the climatology community has, enormous resources to build these enormous, you know, impressive models, and we don't have anything like that in the human system at all. So most of what we're doing, it's not that behind us there's a team of 100 people working on this. We're just cobbling things together on the basis of individually funded grants, you know, and a little bit of core funding here and there. So it's actually, if you stripped it all away, it's not really that impressive at all. Sorry to disappoint you. But we try to do our best. And I think, honestly, I'd have to say, I think the resources, financial resources, are a limitation to pushing forward in the field, particularly in social sciences modelling, because culturally there's a bit of a pushback from the social sciences in trying to take these things forward. So actually getting funding for it could be really difficult.
So the second part of the question
Yeah,
was
what
if
could we do over would what we achieved after 3 years look any different to DEFRA?
Yeah, it could do, and I think, you know, maybe a great thing that could come out of this event for the whole of this month is trying to find out synergies where people can join up and work on things together. You know, there is often this thing about proliferation of models that do the same thing can actually be useful because you've got, you know, different tests and ways of representing processes differently, and you can do comparisons. On the other hand, if you've got limited resources, I think it's probably better to everyone puts their heads together and they start focusing on 1 or 2 model systems, and we learn from that, especially when you're starting from with human dimension modelling, starting from pretty close to zero. You know, Callum's diagram of the evolution of climate models, we're back probably in the 1940s or 1950s. You know, that's where we are. So yeah, let's combine the limited resources we have and try and do something better. So definitely happy to talk about that.
Are you all right to move on, because we have at least another 4 hands up, 5 now. Okay, so this gentleman here has been waiting for a long time.
Can I get back to the issue of feedback, because it was presented like it's a problem, but I would think that one of the main reasons, the only really technical reason that you have to couple models is to be able to represent feedbacks, because otherwise you can just do everything offline, right? You can run one model, then the next, and the next.
I agree.
So I've got 2 questions. Why you are from the same community. Mark has a model full of feedbacks, and Ian has a model without any feedbacks. So how do you decide whether or not to put them in?
I mean, the central model in that platform, which does the rural land allocation, goes through multiple iterations. So it has its own sort of internal feedback. But I think, again, it's one of those questions where actually it comes down to what is the purpose of the model. And with that particular modelling platform, the purpose was to develop a participatory, rapid modelling system. The original target, when we were sort of specifying it, was that it would run all of those models across the whole of Europe in 1 second. That was our goal. Yeah, it was the original. That was the original goal, and we ended up at about 2 minutes. There was a follow-on platform that Mark mentioned. The very imaginatively entitled or named Dynamic Integrated Assessment Platform, which does have the feedback in time, so it runs continuously through the century. The penalty of that is an increased runtime. So yeah, there's no reason there shouldn't be feedbacks, but I think it's what your end of the purpose of your model is, or modelling.
No.
Okay, so Ernest, you were next.
So we're using emulators to simplify the computations of certain aspects of these models. Now we're plugging these emulators into really quite complicated structures, modelling structures, and using these to understand things like tipping points, bifurcation points. Is there not a danger that what we observe through this might be an artifact of the emulation process rather than the property of the model?
Yeah, you can take that one. Yeah.
There's always a danger of that type of outcome, but I think it comes back to what we were saying earlier on Gordon's important point, that we're as much interested in the connections between these models as the actual processes within an individual model. And at least with an emulator, you've got usually a pretty robust, model that will give you what you expect from it. And then you can focus, because again you get the advantages of increasing runtimes, etc. You can then focus your attention much more clearly on the relationship, the interaction between the emulated individual components of the broader coupled system. So I think that probably the advantages outweigh the potential disbenefits.
I think just to add to that, I think the benefit that you get from the faster runtime does mean that it's easier to do the more thorough systematic testing of the model, whether that be sensitivity-based testing, uncertainty propagation, or the like, which would be very difficult to do if you hadn't got that emulation process to increase the runtime.
Chris, you had
So I'm Chris Huntingford. I'm the person who made the Imogen thing you showed, along with Peter Cox.
I know nothing about it, by the way.
Yes, it's really great to see its use. I mean, yeah, it's going to percolate this far, and it's fantastic. But I think just a few points that have come up, sort of maybe from developing that, it's led me to worry about a few things. First of all, the point you just made about could you knock out some of the feedbacks and behaviours? Yes, there's a risk because Imogen is based on linear pattern scaling. That is a worry. The point about the speed is, as you know, it scans across all 34 CMIT5 runs, and of course they're parallel simulations as well. So we can capture, that's one thing I think is good, if you can capture in a simple form the uncertainty. So basically capture the uncertainty in all the climate models. But I think the issue of testing is something we really need to think about. I mean, I do worry about that model because, if it starts getting used for policy applications, that's the idea of it. But, you could find that based on a piece of code you've written, there's some policy decision. And what we did do with that was spent 3 months calibrating it and then attempted to just completely spend another 3 months and rebuild it from the same point. So there's various things you can do to test and make sure that you bit compare. So lots of interesting issues came up in building that thing. And I think it's sort of relevant to hear both concerns and different practices. I think on the funding issue, it was done as a hobby around the edge, I'm afraid. I got in a lot of trouble at work spending time on that and not doing what I was going to do. But that's another story. But thanks for using it. Yeah, nice surprise.
Yeah, I'm not. I guess you've been in contact with some of my colleagues working on the LBJ gas modelling. I'm sure I've heard your name come up.
Thomas Pugh?
Tom Pugh, yeah, he's one. Yeah.
Yeah,
Okay.
it's great.
Okay, great. Well, you can carry on talking
That's great.
over a beer later. With
Just one thing I said, I wouldn't worry about your model being used in a policy context. I'm not saying that it won't be used in a policy context, but you shouldn't worry any more than anyone else should worry about their model being used in a policy context.
Just lose sleep about that. If there was some error in the code and
yeah, it equals every other model.
Yeah.
Well, we did. It depends. Yeah.
Can we move on to Chris?
Yeah, so with two things. One is an answer to the sort of large team envy thing. Someone who's basically not both has generally been a small team person and managed to get promoted twice. That just simply do different things. That often small teams can be more effective at looking at imaginative methodology development. Obviously, there are things that small teams can't do, but there are certainly in the area I know best, which is large-scale energy systems analysis. Big teams have a tendency to kind of carry on doing the same thing. I don't know whether that's the same in this sort of area, whereas sort of people working on their own, as long as they've got the right generally representative examples to work with, can go a long way on methodology. The other thing was just a reflection on what standards are for, because I've been involved in chairing standards group and overseeing another one on electric power system reliability data, standard terms for describing electric power system reliability data, and that's a bit like we are in this world. It's not an area where everything just stops working if we don't have a standard. It's not like how 4G mobile phones talk to the system where you absolutely must have a standard. But one discussion we went through there is that defining terminology or a kind of standard ways of expressing things is very helpful in for helping people talk to each other. There are one sort of controversial area with standards for how one should actually go about doing modelling, as opposed to what higher level goals one should have. I was always very much on the side that one could have sort of recommended practices for things you should think about, but actually kind of try to micromanage the way the world does things when that's not necessary. That's not such a good thing to try and do.
Does anyone want to come back on those comments?
Yeah, I think if there isn't a law, there should be one, because I've got quite a lot of experience of integrated projects. We are trying to integrate different pieces of software, and there ought to be a law that no matter the size of your consortium, ultimately it will boil down to 3 key people who do the key integration work. And in some ways it has to be because of the nature of integration. I think that's really important to recognise. Integration's hard and often falls down to some key individuals that are willing to put in hours and make that work.
There are as many as 3.
Okay, so the last question, I think.
It's a question about model selection. So this came up in a few kind of answers, I think. It's like, what is the appropriate model for your question? I think you said that. And then there's also the kind of big team and the investment as well. So you're going to stick with your model. It's what you're familiar with. You've invested in it. And we all know if you look at a bunch of models that do the same thing, they give you different answers, and sometimes very different answers for very different reasons. So can you say something about how you select models for these coupled modeling systems, and whether you think they're appropriate in a coupled, I mean, if you could go back and do this again, would you try to develop different types of models that were more appropriate for being coupled together and answering the questions that you want to answer in the beginning, in the end?
That's a really interesting question. I should probably pass that over to the coordinator of the project who was involved in selecting the teams. I mean, at a very pragmatic level, the models that were integrated in those platforms were the models for those sectors that the teams brought to the table. One of the challenges, and so I would be very comfortable to say that not all of those models were the most appropriate. And in subsequent versions, one or two of the models have been replaced with alternative models that are more appropriate. So there was a strong element of pragmatism. So I think, yeah.
So we sort of have a mix. I mean, it's a little bit, yeah, you always have a bit of baggage that comes along in terms of, you know, who's got what model and who's available to do something, who's interested in getting involved. And I guess you try and think about best of class, however you want to define that. That can also mean a model that's been around, it's been really well evaluated, it's got resource supporting it like LPJ guess, so that's why we choose that. But I think we also aspire to, I'm not quite sure how to do it technically, I need to buy Gordon a beer in the pub tonight, but the modularity thing is an issue and important to us, and I'll give you an example of why that's important. So in terms of like the crafting model, there actually is no consensus whatsoever about the basic decisional processes that underpin how land users make decisions. You know, we can all have arguments. Brett will say it's economics, somebody else will say it's something else, and there's a lot of decisional theories out there that underpin how people behave and make decisions, and there are alternative representations. And actually what we'd really love to do is not just model with Crafty, but model with an alternative theoretical basis for how the land use decision component is made. And if we can somehow build that sort of modularity capacity, then we could start testing that and looking at, okay, if you do completely change that model, what will be the outcome in you know, what's the uncertainties associated with the structural assumptions embedded within each of those models. And I think that would be really powerful if we can start doing that.
But we sometimes think that a model is sort of one thing, and there's been a number of studies that have demonstrated that if you give the same model to different modelers and give them the same data, the modelers will come up with different answers. So, you know, there are so the idea, you know, the person that comes with their own model, you would hope that they would perhaps produce a better modelled outcome than using a model with which they're not so familiar. But I think we shouldn't forget that the modelers have quite a significant role in the performance of these systems. It's not just all about the software.
Yeah. Last word. The pressure.
Between you and a beer.
Oh, make it quick. Yeah. I mean, the person who's most responsible for me sitting here is Keith Bevan, that many of you might know, especially if you're in the hydrology field. He talks about model selection a lot. He talks about models being hypotheses and peculiarities of place. He talks about testing models all the time against observations and against people's experience, and being prepared to throw out the models that don't work in that particular place. And I think that is so important. He refers to it as models of everywhere, and I think that's a very profound concept that needs to pervade the modelling community more consistently. Yeah.
So please, can you join me in thanking our speakers?